This is the fourth course in a series that is about a math problem which isn't accepted among everybody. It's my own author's math problem. I've been working on it for about 10 years now, off and on, just going back and forth and working on it, seeing what I can add to it if it works, because it intrigues me. I'm looking for patterns. People ask me, where do these equations come from? It's just simple algebra, and it's a pattern that I see. It's a pattern that I find that I'm finding y knowing x. Like we're in an equation where p equals n times q. I am trying to find q in terms of n and p. So it seems complicated. It looks, the way when I write it, it looks complicated because there's equations and numbers everywhere. But that's just how it's formatted in Mathematica. And it's nothing to be intimidated by. If you know simple geometry, simple algebra, it's just setting two polynomial equations equal to each other. And I estimate it's been seen by about 50,000 people. Unique views. Over the past 5 years, I tried to distribute as much as I could, because if it worked, it would defeat RSA. RSA is a cryptography that deals with the factorization of semi-primes. Semi-primes are a number whose factors are two prime numbers. So in my example, I like to use 85 as a semi-prime. 85 is a multiple of 5 times 17, two prime numbers, and a semi-prime is 85. And that's basically what I've been doing. But as you see, I've got a letter here, and this guy actually looked at my work, and he has great criticism, but it's constructive criticism. And I say constructive because of a website called www.constructorscorner.net, and I like it. I see this as, I'm gonna call this, should probably have the C on constructive capitalized, because it's constructive criticism for constructors. We're constructors. We're building stuff here. Even though it might not seem much, I've probably put more effort into this math problem than needed, but I'm just going because it interests me. But he brings up good things like equations, like where they're coming from. And I try to explain where the patterns are, how I derive the patterns, because like I can create a pattern, but when you have x, excuse me, I don't want to use x, but I use x in the equations that I've been writing. But when you have n equals p times q, and you use p and n, well, excuse me, you use n and p to find q, and finding q. But if you know n and p, you wouldn't have to do that, because you would know, if you knew both n and p, you would know q automatically. So my equation, the pattern, if I plug in 85 and 5 into an equation, it might show a pattern, but that pattern is not useful because you have to solve it knowing only n. And that's when I set these things equal to each other. And but he gave up some great criticism here, like this isn't working. The error looks like I'm just plugging numbers, chugging numbers. He mentions the 8-bit keys and stuff, and it's really good. And I did mention calculus, and when you put this on a math board, you're going to get criticism. because like you're just saying you need calculus, but the calculus I was gonna have was gonna be um, as the equations set equal to each other approach zero. There's if you were to use 85 and as your example and find out what x approaches zero, it would be zero. So like as you'd have to check every prime number under 11 where the equation with the error didn't equal zero. I'm going to go ahead and advance the slide. And this is the equation. I want you to look at it. It's not in beautiful format here. It's in number format. It's a program called Mathematica. And Mathematica is just basically a way to program numbers and get graphics and computation and program controllers and such stuff as that. But I've been using it. I did not set these equal here. I'll explain what happened. I cleared x because I wrote this equation. I put PNP is 85, and I didn't put x in. But in my earlier when I was programming this in, I had x equal 5, and you would end up with 0.005 something. So it would be almost 0, but 5 thousandths. But this equation isn't that hard. This is the equations I've been working on. I've just added this new error. Where if you look at the first one, you have EQNS equals PNP to the fourth divided by x plus 2 to, it's not plugging and chugging. That's the I draw that from pattern. But I want you to look at the minus 2 times the quantity x squared divided by PNP, and that would be the error. That little point there, the 2 times the quantity x squared divided by PNP, that's the error. And that's the error of that equation, PNP to the fourth divided by x plus 2 times PNP squared times x squared plus x to the fifth divided by PNP to the third. That's the error. The part I just read you was the error to that equation in a formula that contains x and PNP. And as in the second one, after the minus sign, after the brackets, the minus sign, you see you see another equation. That's the second equation of y as written in terms of PNP and x. PNP is our n, but I couldn't use n because it was a character used in Mathematica. So and x is our p. So that's PNP is the n, x is the p, and we're looking to find j, which is y. In most of these equations I've used, it's a little confusing because I use different numbers, but different representations of variables, but it's the same. But all that is all this is algebra. Y is equal to y. When is y equal to y? Well, we know y is equal to y when we know I don't know. It's a little tricky here. We're setting these two equations equal together, knowing P and P, n. So if we put n in this, Mathematica should be able to solve the polynomial and give us what x is equal to. Like I should be able to put 85 in this thing and have it say it's equal to 5. but it it comes up with the empty set on nsolve. Nsolve is a command to solve a polynomial equation for a variable, and nsolve it should say, like, it should give you numbers. Like, if you've watched my previous course lessons, if you watch the previous lessons, you notice that like, without the error, I had the equation set to each other, and y would come up as x would come up as a number, but it would be like an imaginary number, and then I'd have to find put the error in. But there was a problem because, like, finding the error becomes just as hard as finding the factoring. It becomes more hard than if you just take 85 and divide by 3, 85 divided by 5, 85 divided by... You'd find it at 5 because it's a small prime number. It's a small semi-prime. You'd find the factors fast. But if you had like a trillion, like a number in the trillions, finding the error would become difficult, and also factoring would become more difficult. But you want it so that you want this solution so it's easy. But it's not. I believe it's still not a perfect solution. I didn't test it. I've just done this equation tonight on. I posted it December 8th at 9:18 p.m. I posted this across the web, and it's incomplete still, but I was happy with it. I was like, hey, this is actually making sense here. And so I posted it, and I hope you make this go viral. If it works, look at it, see if it works. It won't do me any good if it goes viral and one person actually reads it and see if it works. It's not successful. It's like it's successful solved, but there's a problem doing the math. I'm doing this in real time, and I got to get people interested in it, and then I got to explain how it works, and then I got to deal with why it isn't working, and it's just gets complicated. But I've posted this to the web. I posted it. I'll be doing a follow-up on this lesson, and I'll have links to where I'll have a link to download the Mathematica file. But right now, just look at it, and if you see my previous work, this should sum it up. But it's close, but it comes down to the fact: can you solve the polynomial to find x, which is also called p, and the n equals p times q equation? Can you find x knowing only p and p is equal to 885? We've eliminated the y, so we only have one variable. But it comes down to being able, for Mathematica, to be able to factor this polynomial. And there's the question that if the error is true close to 0, if it's 0.005 for 5, and if it's 0.000 something for 3, that's both pretty close to 0. It would limit the amount of numbers you'd have to try, but that's not the kind of solution I want. I want a polynomial time equation that will give me an answer. I could run a loop for the error and keep step through, like, the error of, for instead of adding the 2 times x squared divided by p and p, I could have a step the error, like the error is 0.1, the error is 0.2, the error is 0.3, I could 0.4, 0.5. I could keep adding the error on because these patterns I found the square roots, and it's causing the that's causing the error, the error of the pattern, because square roots of numbers are, I don't want to say irrational, but they're um it just gives you, like, instead of saying 17 for y, it'll say 17.2 or 17.5, and the error is there. But I think that's all for now. I'm gonna put this on YouTube, and I'm gonna have a active class. The more people you see this, share this link on YouTube, and tell me what you think. And over this is for a class I'm taking in adult education at Point Park University, and of Pittsburgh, and I have to teach a lesson, and I've only have so many slides prepared now. I did pretty good, like, discussion. I wish I would have had more slides prepared to go through during this discussion, but this is only the beginning. I'm gonna add to this discussion as people ask me questions. Like, if they email me a question at go to constructorscorner.net and get my email address on the contact, and email me, and I'll build this in real time. And if you want, like, what is the final goal? The final goal is that we'll be able to defeat RSA cryptography. And if you didn't know, RSA is based on the integer factorization method of semi-primes, which I described earlier. And if you could find in the equation n equals p times q, which we talked about, if you could find q and n, knowing only one of them, if you only know n, and you can find x, if you only know n and you can find p, you've just broken the one-way function that secures RSA cryptography. It'd be like, there'd be a key, like, say it's a 256-bit key, and you could type the key into a program, hit enter, and it would crack it. There's more to it than just the prime factorization, but the prime factorization is the main weakness of RSA cryptography, and that'd be great. But that's wishful thinking. You have to make sure the math is sturdy first before we go to jumping to conclusions. Like, I like to add excitement to my problems and say, close to the RSA being no more, like the end of RSA. It had a good 40-year run. Let's just break it and destroy digital signatures. And no, but we're not trying to destroy here. We're just trying to be a code breaker. Like, just like how I heard it put is, like, there's a code breaker and there's a security act, like the guy in ciphers. Like, there's code creators and code breakers, and the guys designing the codes are always trying to design more and more. So those that break the codes are always trying to catch up and trying to break the code. It's like spy versus spy in Mad Magazine. Like, sometimes a white spy wins, sometimes a black spy wins. It's a competition. It's not for destruction. It would be interesting to break RSA, but the only reason to break it is because it's there, and it's not supposed to be broken. It's like they're saying, like, this thing's unbreakable, but if we break it, we're just playing mental sports, like we're playing it's a competition. Can they encrypt more than I can decrypt? It's a lot of fun, and I'm gonna end here. But I hope you enjoy this. And remember, that's www.constructorscorner.net. Thank you.